In this video, we're going to look at how to find the gradient of this graph at 225 seconds. And if you look at this graph, it might look like a straight line, but if we put a ruler alongside it, you can see it curves slightly. So if we want to find the gradient at 225 seconds, we should put a little spot at 225 seconds, and then we should try and draw in a tangent to the line at that time. So to draw in a tangent, we need to line up the ruler so that the ruler just touches the line at that point. And once we've lined up the ruler as best we can, so it's just touching the line at that point, the 225, then we want to draw in a line, a straight line as long as we can. And we can see this isn't curving very much, so my line has kind of gone over the curve for quite a long section, but hopefully roughly centered on this point. Once we've got that straight line, it's just like finding the gradient for straight line graph. So we need to draw in a triangle, and I'm going to draw in a triangle that's nice and large. Exactly where you do it doesn't matter too much, but you want to make it nice and large, and ideally choose it so that it's mostly on points which will be nice and easy to read. So then to find the gradient, I need to do the change in the vertical divided by the change in the horizontal. And for the change in the vertical, I need to do the final value in the vertical, which if I look here, the final value is halfway up that third square, which will be there, which will be 2,900, halfway between those two. So that will be 2,900 minus the starting value. And the starting value I can see is 3 little squares going up from 1,600. So it's worth working out what each one of these little squares is worth. So one little square is going to be worth whatever that difference is, 200 divided by 5, which gives me 40. So that tells me that each little square is worth 40. So this would be 120 more than that, which would be 1,720. And then if I do 2,900 minus the 1,720, that gives me 1,180. And then I need to do the change in the horizontal, which is a lot easier, which is going to be my final value, which is 225, minus my starting value, which is 125, which gives me 100. And then to work out my gradient, I'm going to do the change in the vertical, which was the 1,180, divided by the change in the horizontal, which is 100. And that comes out equal to 11.8. And then to decide on the units, I need to do whatever is on the vertical, which, let me write it here to give myself a bit more space, is meters per second, and then divide it by what's on the horizontal, which is another seconds. And so that becomes meters per second squared, which gives me a clue that what I found is the acceleration, because I've done the change in velocity divided by the time taken, which gives me the acceleration, or the gradient of the graph, is 11.8 meters per second squared at that point of 225 seconds.